Oh, it's really very nice seeing you all.
Yeah.
And I think now is 11. June,
Okay.
you're allowed to take this away.
Okay. Good morning, everyone, or good early morning, good afternoon, good evening to some of you. We're really thrilled to have you here. So thank you for joining us this morning. We're looking forward to talking with you about our work that is focused on introducing programming to support the learning of elementary mathematics. Let me just go through a couple of logistics here. I think that most of you already are doing this, but if you could just mute when you're not speaking, that would be great. And also, we have some time for questions at the end, but also if you could just type your questions into the chat, we'll also monitor the chat and, you know, either raise the question in the whole group or ask you to unmute so that you could ask your question directly. So I think that's some of the logistics. And so I think we're going to get started. Welcome to SnapCon, because I think this is the very first session, and welcome to our session. I'm June Mark. I'm from Education Development Center. We are in, well, we're in the Boston area. We're all in our own homes at the moment. But that's on the East Coast of the US in Massachusetts. And I'm here along with my colleagues, who I'll introduce in a minute, to share some of our work, which focuses on using programming and specifically using SNAP to support young children's learning of mathematics. With me here this morning are Paul Goldenberg. Can you guys just wave?
Hi.
Deb Spencer, Kristen Reed, Kate Coleman, Zach Kohler, and Bernat Romagosa. Hopefully I'm saying that correctly. Let me start by sharing the screen here. So we're going to be talking about our work. We call it the Math+C project, but its focus is on using programming to support learning of mathematics in the elementary grades. Let's see, I'm trying to forward my slides. Okay.
There.
So here's many of this team are on here on this call today, but we're excited because this team is a close collaboration amongst mathematics and computer science educators, curriculum developers, education researchers. A number of the team also have classroom teaching and math coaching experience. That's the folks at EDC. We also have really appreciated our close collaboration with Bernat, who's part of the SNAP development team as well, and Zach, who works in an elementary school that nearby where we've been testing, but has joined the team to support some of the SNAP work as well. So as I mentioned, we are working closely with classroom teachers, math coach, a digital literacy teacher, as well as a principal who's facilitated some of this work. That's the second grade team that you see in that picture there. And that's been a really important piece of us being able to do this work here. So, you know, I've mentioned that the work has been about introducing programming at the elementary grades, and our hypothesis is we think that programming can be a language for students to express and explore mathematics. Oh, shoot. John.
That'll keep happening.
Hold on one second. Sorry.
This you know,
Sorry.
The idea is that the languages children have already aren't fully sufficient. their spoken language and the written language of mathematics, and that programming might be able to fill the gap. Go on, June.
Okay, so sorry here.
Meanwhile, I was filling the gap.
Doing this from home. Just a few words about our project goals. You know, as we said, the top level goal is the learning of mathematics for kids. To do that, we are developing these exploratory programming microworlds. And by that, I think we are creating these environments within SNAP, and the goal is to limit the distraction for kids within the SNAP environment, and also the amount of text, limit the number of blocks so that they can really focus on the challenges and puzzles that we're offering and the, you know, the mathematics tasks that they're working on. We are starting at second grade, partly because the notion of building on a language, building programming as a language that grows with the children through the grades, but also grows with the mathematics as it develops throughout the grades as well. The work involves testing and a process we call iterative development and refinement. And basically what that means is we're doing very close work with students and teachers. We bring the microworlds into classrooms. We see how students react. We make changes, sometimes even like that very evening, and then go back and test further. And we're doing that, you know, multiple times across the year. So we have very kind of immediate feedback on some of the design and development that we're doing. The project also includes research that's looking at children's development of language in this programming environment, and also they're thinking about mathematical ideas and also computer science and computational thinking ideas as well. A number of design principles really guide the work that we are doing, and I just wanted to talk a little bit about them before Paul does some demonstration and introduction of those micro worlds with you, where you'll actually get to see them and if you want to play with them as well. So one is it's focused on the most critical mathematics content for the grade. And so in like grade 2, that includes addition, subtraction, place value. In the later grades, that in the upper elementary, that includes also multiplication, division, fractions, decimals. Part of the reason we narrowed in and focused on that most critical mathematics is that this work in the classroom time is precious, instructional time is precious, and to be able to engage teachers, it really, the enterprise had to be seen as enhancing and supporting the mathematics, not viewed as extra work or something that was tangential. The use of an accessible programming language, most of you know how SNAP being visual, block-based, easy to learn and use, that was part of the appeal to us. But also we were attracted to the capabilities that SNAP has that really support mathematical thinking and how it, both the functions and how it's consistent with mathematical logic and behavior. We've built micro worlds that try to provide some structure and scaffolding, kind of limiting the distraction in the environment, but also a key element of the design is a set of puzzles and challenges. They are appropriate developmentally, but they also grow and become more challenging as students become, you know, welcome that challenge, and students have some choice about how they move through those sets of problems and challenges. And like at the very simple level, it might be in our number line environment, asking students to start by labeling the numbers 1, 4, and 7, or in our place value environment, asking a challenge might be building a script that makes 152.
All of which will be easier to understand when you see these.
Right, much easier. So just a couple quick more of other kind of design principles. Experience before formality is a notion that has pervaded much of our work in mathematics and computer science education, you know, for decades now. The notion is that students are offered opportunities to explore and experiment in these environments. They try to express their ideas in like simple scripts, and what they're doing is learning from that interaction. They actually can see the results of their actions, and our belief is that kind of foundational experience, it supports the later formality that students will see. Centering the locus of control and authority in kids. I mean, we believe in kids being in control. We think that leads to greater engagement and is also more faithful to the mathematics. By allowing students to work in the programming environment and get immediate feedback on their actions, we feel that that allows students to kind of judge whether their own methods and their results make sense. So they get that, you know, did I actually make 152 there? And they can see without what we see in a lot of math apps is behavior where students get like a yay or nay. But in this case, the authority is really residing in the child looking at whether their methods and results work rather than having some external authority. And last on this list of design principles is we've tried to design the environments so that they serve multiple grades, and partly that is also to be consistent with the kind of consistent and coherent mathematically, so that students will see that they might work with a number line environment first with small integers, but the behavior of that environment is going to be very similar if they're working in thousands or if they're working in fractions or decimals, so that they have that same behavior. So that's the kind of set of principles that's really guided some of our development. We've started at grade 2 and have created 4 environments: a number line environment, a place value environment, one that's a town map, and an arrays, which is early, it focuses on early multiplication, but that will also extend into the upper grades, upper elementary grades. Paul is going to show you those environments and also show some extensions and possibilities for the upper grades. So Paul, I'm going to turn that over to you. But one thing I just wanted to say, I've put the links here. I think we're going to try to put the links also in the chat, and they are also available in the abstract for the session. So.
June, they are in the chat.
Okay, great, thank you. Paul, I'm going to stop sharing and turn that over to you.
Okay. And there we are. Does everybody see my snap screen? Yeah, except me, I don't. Does everybody else see the snap screen?
No.
Okay, let's try this again.
There it is.
No, we don't.
Okay, great. Okay, so I wanted to start just by saying what do kids need to see before they start? We want the briefest possible presentation to the kids for 2 reasons. 1, they're little kids and they don't want to be sitting around getting lectures. But 2, for the sake of the teacher, for the sake of our building an environment, we want one in which there's no distraction from the lesson. As June said, time is precious, and the kids need to be focusing on whatever that lesson was intended to be about. Teachers can't give up that time. So let's see. I will try to present this more or less the way I present it to kids. So what do you see here? A bunch of junk. Oh, Dinosaur is saying press any key to start. So I'm going to do that. And what does Dinosaur say now? Dino. So the kids read it. And you can move the circle by dragging out a blue block and clicking on it. They don't know what that means. The very first contact with Snap. So I would say, well, it looks like that. Nothing happened. Oh, right, I forgot to click on it. Click. That's what happens. Who would like to come up and show us how this goes? And we call up a child, the child does it. Now I'll skip the time that it takes for a child to get up, but it's pretty fast. And child might drag out another block, or that's not an interesting block. Let's try that one. Nah, let's try that one. Because okay. Oh, what's that? So the children play a little bit. And I start it by saying, okay, how many languages I'm sorry?
Paul, I'm so sorry to interrupt.
Yeah.
What I'm seeing is your screen with other stuff on the side as well. And I'm wondering if you just show the Snap window so that
That's what I thought I had done. Let's try that again.
Okay. Sorry.
Sure.
I think it will have the effect, Paul, of making it a little bigger.
Oh yeah, well that's what I had hoped I was doing.
Now you're doing it.
Yes.
Ah, okay, fine.
Thank you.
Perfect, perfect. Thank you, June, for telling me. That's what I thought I had done. Okay, fine. So one of the things that's going on is, I'd say to the kids, how many languages do people speak here? And we live in an area where that always gets lots of different languages. So Greek, Dutch, believe it or not, in one class, it's not so common around here, but that happened. So this computer, it doesn't speak any of those languages. You're going to learn its words. Now, those are these blue blocks and this green block, but we can also make sentences out of those words by snapping them together. And let's see. What do you do if you don't like all that stuff and you want to start over again? So there's this. I can start at 0, or I could actually start at some other number if I wanted. That's the introduction. There's very little more to say to the kids, except after you're tired doing this, you should do it a little bit, play with it. You can pick another exploration, like that one or that one. And then go away, and the kids go back to their desks and they play. Meanwhile, they've seen, you can't say learned, they've seen the idea of giving an input. I didn't actually use it this time, but there you are. And restarting and cleaning the screen. So for this particular exploration here, one of the second graders this is the, I think it was her second contact with this, said, oh yeah, I can get to all the numbers. All I have to do is go to, let's see, +3, +3, and -5. And let's see, +3 + 3 gets me to 6. And then -5 gets me to 1. Yeah, if I put those together and I just click it 15 times, there. Oh, wait, we click too fast. These little kids are enormously fast, so we'll start at 0 and be a little bit more patient. So there's a second grader and second contact with this, articulating mathematical induction. Also, I showed you that the problem of woodpecker tapping, that really teaches us to be a little bit humble. There's a lot of stuff underneath these blocks. This looks like a fairly straightforward draw a little arrow and label the block. In fact, for second graders who are inclined to do multiple taps, you have to build a lot. So let me show you what happens when you don't. This is the way it was before. I've created a disabled environment here. When we first went into class, we would see, I'll show you again, this works if I am like an adult and I click slowly. But if I'm a child and do this, it goes all over the place. So you have to build lockouts. And that's actually one of the reasons we wound up going to Snap rather than Scratch. We had proposed Scratch to the NSF because that's what's familiar to teachers. But algorithms need to be algorithms. And so we need to have things behave properly the way children would expect them to behave, even if children are fast and impatient. So one other thing, there's Olivia's block, or there's Olivia's script. What she really wanted was an additional block. I mean, she is +5, +3, -3, -5. She really wants +1. And this does a whole lot of jumping. So we can turn this into a block, call it +1. And there we have it. And now a little +1 block. Oh, well, we don't have a script. It's all there, but it's still doing all that jumping. We originally wanted to do something a little fancier for the kids. The kids understood it, but we decided to, I've just hidden something on the side because we decided at the end not to include this. Actually, let's start at 0. Let me just show you what this does before I make the block different. You know what this does? But what the kids really wanted was that. Kids all understood it. We decided not to provide it for the kids after we had built it and provided it for the kids. Not because they couldn't understand, but because we felt this might be a distraction from the mathematics. So there, just to show you what is possible. Again, something that we needed Snap to have the capability to build. Okay, onward. Much briefer introduction. Oh, I did want to also point out, wait for it. We needed something else. We needed to be able to control the fact that, not all of our children speak English. So Zach built this automatic translation. It doesn't do the translation itself, but just using the language support that is native to Snap. He also built some support so that using that, we get translations of the blocks and the text. June mentioned that we tried to build environments that would have legs that would extend beyond. So here's the same environment. I won't show it to you in great detail because there's no point in that. But we can see this, and so we deliberately made this report only in eighths so that children don't have to deal simultaneously. Well, 3/8 plus 3/8 ought to be 6/8. Kindergartens will tell you that without knowing what an eighth is. But we did decide also to leave this these integer landings labeled. And that's something for kids then to begin to wonder about. I mean, what's going on here? And finally, we want this will show you no blocks at all on the side because it's just a demo. But we want to be able to show as well what happens when we, oh, this is not working. Why is this not working? Yes. I have a number line. This is now labeled in hundreds. I did forget to show you something. So I'm going to go back. Back in this number line, for the second graders, you may recall that they had there's a puzzle. Is it all right if I keep it in Spanish? See if you can make a script that begins at 0 and ends at 6. It'll just have to ring. Later on day 3, they have a similar puzzle, but with different blocks. Create a script that starts at 0 and ends at 600. And notice that they now have hundreds blocks. They haven't studied hundreds, but to the children, because the language feels like it ought to mean the same thing, this is not a mystery to them. Just as the kindergartners would respond to 3/8 plus 3/8, 300s plus 300s, 3 millions plus 3 millions. And now let's move to decimals. So here's a number line. It's labeled in hundreds, but I would like to scale down. I'd like to look at this one region and just see what's in it. So we can. And now I can move to some spot within it. So let's make a number line. Let's mark 2 spots. Let's scale between them. Let's label 2 spots. We can scale between them. Let's label 2 spots. So kids are getting this sense of the number line expanding, and there's more stuff on the inside. And it all feels ridiculously familiar because it should. And in 4th grade, we want to scale there too, and label a spot and label another spot, and we could scale even further. But I will save you the trouble because you know the math. Let's move on. Some of our children don't read or don't read very well. So we actually want some support for a sentence like this.
Drag on blocks and click on them to make Dino say more numbers.
Was she audible? Yes. So that's one of our 4th graders reading for the 2nd graders. So the programming isn't actually very different yet. We're still, this is the only 2nd contact the 2nd graders have. And so we still want rather command level things, but here, build a script that makes Dino say 20. Do that. Oh, and it does it a little differently. We don't have a number line, but Dino now says things. We're building scripts. We're focusing on that. And we're focusing on combinations of numbers. Like one of them is get Dino to say 9. So some kids go 1, 1, 1, 1. But they get annoyed at that actually themselves. Spontaneously, they don't like the feel. They're working with trackpads. God, it's hard. You're going to see in a moment. And some kids spontaneously get ideas like this. Let's start with 0 again. I did it. That's the word that's the phrase that they all use. I did it. So we come over and watch. On day 2, they get some new challenges, some new puzzles. And puzzle 1 is interesting. Make dinos add 100 4 times. Well, let's see. 3 times. So this is beginning to suggest a little bit of using, not combined steps, sorry. I got myself confused. Start with 25, build a script that makes dino say 152. So that's a bit of a mathematical challenge. It's also something of a programming challenge. So I want to start with 25. I'm going to skip over this a little quickly. You know what the programming is. But now how do I think about this? Well, do I want to move dino up to 30 so that I can start using tens? Do I want to move it up by hundreds, 152? The children have choices. And again, they're the arbiters of what works. A really cool problem is having the kids make a number like 291. And there are a lot of different ways. This is, whoops, sorry. 0. Here's one way, and it's painful. We can go through all of this all the way down. I won't. Another is to repeat. Let's see. I don't have the repeat here. Yeah, there we are. Another is to repeat 200. Repeat 90. That should have been 2. And 1. That'll do it. That's kind of long and draggy. I don't want to watch it. Another way that the kids come up with is, so this first way is literally building step by step. The second way is what schools teach as a kind of expanded notation. The third way is a mental computation idea, which is much more like round and then adjust. Whoops. 300, nope, 291. Well, if I had started with 0. Onward. I'm going to actually let a child show this one. I won't show this myself, but I did want to show you one thing. The children love to personalize this. This is going to be, you know, kids visiting other kids. And so they could make this Deb and now we have Pizza Hut and Deb and Jen. And of course, the puzzles will recognize these, but I'd like to go ahead and have the kid show this. So I'm going to stop sharing this and attempt to share this. Do you see the movie?
Yes.
Make a path from Mara's house to walls and cells with only one turn. Okay, I'm gonna do that. You're gonna do that. So you come here. 1, 2, 3, 4, 5, 6, 7.
Oh, okay.
So
How would you start?
it says to start at my house.
Where does it say to start?
It says at age 6.
Age 6.
I'm gonna press.
Oh, I see. Oh, I see your smiley face moved.
Okay, I'm gonna go 1, 2, 3, 4, 5, 6, 6 pesos. 1.
Okay.
It really does say
That's
pesos.
west. Here. Okay, 6 times.
Yeah.
Okay. This is a turn and 1 up. That's north. Up.
Working with a trackpad is really difficult for a 7-year-old.
Sticking to your cursor, huh? Okay. Oh, get in there. Good. Okay. Now. Ta-da!
That's with just 1 turn.
That's with 1 turn. How long is the path?
And it's 1. This was 6, 7.
Yep.
So he
Okay.
recognizes his
All right.
repeat
We'll
6.
go to extra 2.
I should say, this is the follow-up. This is a child who's actually played with this for a couple of times, and Deb right now is interviewing him to see a little bit more about his thinking.
Make a path from Laura's house to Lucy's house that turns more than once.
Yes. Same places, more turns.
So now I have to start at Laura's house.
And start at Laura's. Yeah.
Go to my house.
Yeah. Can you do it with more than 1 turn, do you think?
Yeah.
Yeah. Okay.
That's gonna be easy.
Oh, there it goes. There it goes.
Okay. Okay, now I'm gonna go here. I'm gonna start at Laura's house. Where's this one?
We have to say the kids have not been given any instruction on coordinates. I mean, they got a little bit of experience on the floor doing this on a physical layout of a map, but no instruction.
Smiley face.
I'm gonna go 1 down. 1 down. 2, 3. 3, 4, 5, 6, 7, 8, 9.
You notice he actually gets to the number he anticipated, even though the counting really doesn't look like that.
I'm gonna go down 1, 2.
Okay. What
That's
direction is that? Is that what you mean?
Now I'm gonna go 1, 2, 3.
So teachers often anticipate that they
6,
need to pre-teach
Okay.
northeast, south, and west. But in fact, some of the kids who don't really follow that teaching figure it out anyway. Watch this. This is very cool.
Okay. Oh, you got to repeat inside of a repeat.
He did
What
that
if I
because he
do
was
that?
trying to change
What do
the
you think
input.
would happen?
Oh, I'm sorry.
I don't know.
You can always try it.
Okay. I wanna write it down. What?
Yeah, it only did the 2 yourself. Well, you don't have anything inside that repeat block right now, so.
That's weird.
Yeah, I think
He's
it's because
puzzled that it didn't
have
go
on
west.
repeat 0. So when it says repeat 0, it probably doesn't do it.
So No, what did I say to him?
I think you wrote six, didn't you?
He recounts.
6 East. Okay.
You're so close.
1 up. That's
What direction? How many blocks long is that path? Remember, your other path is 7 blocks long.
6.
Wait a minute, you did that so fast. How did you know 9? You didn't count them.
Because while I was going down, I was counting how much there was.
All along. And then did you add it up?
It was 1, 2, 3, 4, 5, 6, 7, 8, 9.
So that was with the counting, but what was the fast method that you used?
Children often give much more detailed accounts of slow ways of doing things than what they actually did in their head. So watch.
So while I was putting them down, I was counting how much I need to go down.
Oh,
And
so
I
that
knew
was 2.
that was 2, then 3, 4,
Yeah,
5,
again.
6, 7, 8.
And then you have 1
Or
more.
if I didn't do this, I could just add 2 plus 6.
So I want to go back briefly to the snap screen, if I can again find it. There. Are we here again? So very beginning environments. This is the first one that has substantially new programming. It requires sequence. It's certainly much more complicated. You noticed in that previous one, because the child is trying to do things, they're always debugging because they're evaluating the outcome. Well, there's even more that's going on here. So this has a focus on inputs. Several of them have inputs, on sequence, on steps. And I mean, I could show you, it's better if you just play with it. June, if you could, I will unshare for a second, just show the couple of slides of kids' productions in that environment. And then I will show the last sample. So it's slides 10 and 11, I think. Oh, that was a kid working in the, yeah. So here's one. And there are a whole bunch of, you know, these are exploration 1 and a script, exploration 2 and a script, all of the scripts that the child produced. And the next slide. And some of this is a very long, the script runs off the screen, but the kids get interested in the designs, but there's also a lot of thinking about how to build that design that's going on. This is, remember again, 7-year-olds, this is their 3rd environment, and that's a 4th environment. So they've had, you know, something like 7 days of programming before, there were 8 days of programming before this. So I want to show one last thing, if I can again share. Yep.
I'm going to interrupt you for a question from the chat because it's relevant to the piece you just did.
Okay.
Mark is asking about your comments about some of the difficulties kids have with the trackpads and wondering if you saw a similar difficulty in the logo days. He obviously knows your history. And he says, I'm asking you to contrast text with cursors versus blocks with a trackpad for young children.
Well, each one presents a difficulty. For 7-year-olds, text is pure hell. that you get, there are a lot of things that make it much easier, but there's a lot of typing. You have to do many characters and you have to spell it right. And in fact, that one of the reasons why we think that programming has an advantage over mathematical notation for learning of mathematics is, just think about it. A kindergartner can write a sentence, misspell most of the words, and you still know what they meant. But if they miswrite one character in a mathematical expression, the whole thing is unintelligible. And furthermore, you don't actually know which character caused the error. Ditto with typing. But it's physically easier than the trackpad. Kids don't have a hard time picking up a mouse. And it may be that we haven't had a chance to experiment with tablets, but moving the blocks on tablets may be easier. There are inherent problems with, you know, the block versus text. You know, if you're trying to edit and things are very complicated, things run off the screen. But the kids seem to manage that moderately well.
Paul, can I interject just to say that this past year we tested with 80 children approximately across 4 classrooms, and we did see a remarkable, for most of our children, it was their first time using a computer, many of them, not, and we saw a remarkable learning curve. So while these things were difficult, we also saw a lot of growth, and a lot of growth happened relatively quickly. For most of our children, it was the first time they'd ever logged into their computers. It was the first time they may have even used a cursor, that they use a trackpad, etc. So we were amazed at what we even saw for each of our times we were in the classroom between the first day and the second day. And the teachers saw that as well, and they were gratified. It seemed to help that they were using the computer in order to do something they wanted to do and not just sort of practicing the skills. So there was a lot of motivation to learn how to do it. Dragging and dropping blocks was probably the place where we saw the most challenge remain.
So I want to end, because I want to allow a little bit of commentary on the building of these microworlds, and also allow time for questions. But I did want to show you, I mentioned here that the language is a little bit more, programming is a little bit more complex. That matters, not because we're trying to teach programming, we're trying to teach math or let the kids explore math. But as their mathematical ideas evolve, the programming needs to also. So we have an environment here with a bunch of puzzles that are like, well, I'm going to skip this. I'm just going to go in order. It's claimed that kids have a hard time with lists, but if you ask them to make a list of numbers from 1 to 5, they, if they've had any experience with this before, they get that idea. If you ask them to make a list of numbers that's just even numbers, like a list of numbers from, let's say, 0 to 10, they could do that here, but only just even numbers. So you have to show them, you may not have to show them this.
Paul, I'm sorry to interrupt you, but I don't know if you think you're showing something on the screen, but you haven't shared screen.
Oh. Yeah, sorry.
That's okay.
I didn't realize I was not sharing anymore. Okay. Well, I certainly did think that I was sharing. There we are. Everybody see it?
Yes.
Yes? Okay.
It's your whole screen again, Paul, with the stuff in the background as well.
Share. This should be.
That's it.
Okay. I swear I did the same thing. Anyway, so the kids with essentially no instruction, they anticipate that if you want to make a list of numbers from like 0 to 5, this should do it. And it does. They can't anticipate that if you wanted to double all those numbers, that multiplying by 2, I mean, why should they believe that this would work? So, and in fact, it didn't work until quite recently in SNAP, but this you have to show, one example. And then you can give a problem like, how would you make odd numbers from 1 to 11? That's actually not so much a programming problem once you've done things like this. That's a mathematical problem, and it turns out to be quite a hard one. You'd like to have the kids imagine, oh, well, just add 1 to that. But there's a lot of processing going on here, a lot of embedding, and this takes experiment and play. And in fact, we've done this with, so the beginning of the year, 6th graders, so think of them as aged out 5th graders. We are this year going to try it with aged in 5th graders. But this kind of thing and testing to find out whether a number like, is that an integer? No. I mean, meanwhile, they're, you know, playing with mathematics that they ought to know. And then again, something that they have to be, a kind of thing that they have to be shown, but they now get some idea, oh, first, I want to do a simpler test. What about this? Well, let's see, what does this do? What does this do? And so that they can gradually work up to filtering lists and checking out divisibility. So enough. This is a presentation of the nature of these environments, the constant focus on mathematics, and the ways that children can grow pretty much through their own experimentation, which is the way kids learn anyway. I will unshare and onward. Kids are engaged, and Kate will say more about how teachers react, and we don't have a lot of time.
No, I'm going to be actually quite brief. Just to share a little bit of background about me, I have been an elementary school teacher and coach. And one aspect of the project that I've been working on is working in very close collaboration with our Plimpton School teacher partners on the development and research, including, like everybody has said, the classroom observations we've done, cognitive interviews of students, and we've also done teacher interviews. So just very briefly, and we actually just recently did these as a way to sort of wrap up our experience and gather impressions and experiences that the teachers have and solicit their feedback. So these are just some themes that came up that teachers found from students working in the micro world, that there was a high level of student engagement. Students were all highly engaged in the programming, and the teachers even reported that for students that often may struggle to engage, specifically in mathematics, that those students were eager to learn and showed tremendous persistence. And that was something they don't always see in sort of the typical classroom instruction. So I think for a number of these teachers, there were students where they had this like big aha. One quick snippet just to mention is one teacher even reported that in her classroom that students chose to do more programming in our micro worlds when they earned a classroom reward. So in lieu of doing something like a pajama day or watching a movie or whatever, that's what was selected by the children themselves. Teachers also, common theme was making student thinking visible, that because students were able, June, you touched on this earlier, were able to show their thinking and then make adjustments based on this instantaneous feedback that they were getting through the environment. They were able to adjust, and that relates to this third bullet of experience with debugging. Teachers reported that, like, this was a perfect example of where students were sharing this common experience, but approaches in how students would debug a script varied. So one teacher reported, you know, some students would sort of go block by block and test out to see what was working, whereas other students would build a whole script, run the script, and then find within that script where that point was that needed some adjustments. And then in talking about their work, the students really became used to using some of this programming vocabulary, like using the word script, when they were talking to the teachers, and our team observed that as well. We sort of touched on this, the last two bullets, so I'm not going to really say too much, but just this idea that there really was this fast learning curve for students who hadn't had any prior experiences in programming or even logging in through Google Classroom. You know, there's an initial learning piece, but they caught on very quickly. And then, as we mentioned already, the accessibility with audio, translation of the environments, and language support was huge for teachers. They found that made working in these micro worlds within the classroom, given the composition of their class and needs, et cetera, that it worked very smoothly. So I'm going to stop there, and I believe Bernat is next. I'm going to turn it over to him.
Okay, I promised I'd be very brief, and now I'm actually going to have to keep my promise. So I just wanted to tell you about. No, that. I mean, the interesting part was the one you heard up until now. I just want to share my part of the work here, which was a technical assistance and creating the snap fork that enabled all these microvolts to be built. Initially, I created a big hack I'm not very proud of that got very hard to maintain, and changes needed to be propagated throughout several projects. It was really slow, and a little before New Year, I think, Paul, is that right? We started working on a new snap fork. It just has a few modifications to accept new tags in the XML that we export projects in Snap to. So the Snap file now has some extra information that this Snap modification can read. And these new tags, this new information defines the following. It's you can define an overall microworld configuration, including the zoom level of the blocks, whether to enter the microworld when the project is loaded, whether to enable keyboard editing, and so on. What else? Buttons, their placement, labels with translations and actions to all of these buttons. The blocks palette specific to each microworld, which parts of the UI you want to hide, if you want to hide the sprite corral, or you want to hide even the stage, you can hide all sorts of things. And what menu options to show for the project and settings menus. And also temporarily to cover anything I haven't yet implemented, there's a piece of custom JavaScript that will run when the project loads. And then additionally, I also implemented libraries for this. This might be useful to people not using microvolts, but using Snap in general. I made libraries for pulling images and sound from a server on the fly, so your projects don't end up weighing hundreds of megas. And also an enhanced speech bubbles library that can display images inside of speech bubbles and can have text styling. And to complement that, also a LaTeX to image library that you can use to embed formulae into enhanced speech bubbles. And let me just, for the more technical folks here, I'd like to share, if I can find, can I find the chat somewhere? Yeah, here. So here you can find the fork, the snap fork that has all these modifications. And here you can find all the documentation. I unfortunately forgot to copy the links to these libraries, but as I mentioned a little bit before in the forum, in the chat, you can head to the forum to continue this discussion offline after this talk is over. It says not found. What does the forum or the GitHub links?
The GitHub links.
Oh, really?
Yeah, the first GitHub link. Thank you, Bernat.
Okay, I'll correct that.
Yeah, we'll continue in the discussion forum, but I just wanted to acknowledge that this work was funded by the National Science Foundation, and we're through the STEM+C program, so we're really appreciative of that support and being able to do this work. And I think we're at time now, but we'll stick around and take some questions. And you can also feel free to contact any of us via email here.
Thanks, June. Our plan was 20 minutes of question time, and somehow or other things didn't work. Mostly mine was long. I expected it to be extremely short.
June, would you be able to put the email address slide? Yep, perfect.
Thank you, everybody, for coming.
Yes, thank you very much. And we'll stick around if there are any questions for a little bit before heading to Jens's keynote.
Thank you.
Thank you.
Thank you all.
Yes, thank you. This is very interesting. We work with K4, actually we work with all kinds of kids. So it's always fun to figure out how to do programming and math with the littles.
Yeah. Where are you?
So we're in the high desert of Southern California.
Uh-huh.
Wow.
Like north of UC Riverside, on the way to Las Vegas. That's where most people know we are.
Great.
So we've used Snap or Scratch Junior because of the pre-readers.
Yep.
And so that's always one of the questions is how do you bring it down to the pre-readers? And somebody had mentioned using audio, and I hadn't thought about that before. Is that something you can build in like as a widget to the buttons? Or like how do you think that might work?
Yep, we've built it into our environments. Zach, are you still on?
Yes. Yep.
You want to speak a little to that?
Yeah. So so the audio in the environment is right now I think it's just tied to the puzzle text itself. And I think at least in the environments we've done so far, the actual blocks don't require a ton of reading. Because they're like you saw in the Numberline world, it's mostly just plus and minus. And I think each world only adds like 2 or 3 new blocks. And like for the most part, like either they do similar things, like they're adding and subtracting, or like in the map world, it's kind of clear, like the just what each one does. So I don't think that would like, I think the puzzle text would definitely be the trickiest part. And then like, that's the part that you can, like you just click on the dinosaur or whatever character and you hear that out loud. And then that's what kind of levels the playing field, then brings it down to students who, like, I know we have, when we were working on this, we had some students who were relatively new to the district and primarily only spoke Spanish. And we have a couple teachers who are able to translate enough, and sometimes other students help them. But I know in one class in particular, there's a teacher who, she said through the micro world, like this was the first time she was able to see like what the student is capable of mathematically, because the language wasn't a barrier. And in that case, it was more like the language than actually reading abilities. But in that case, I don't think it was, like I know many of this, or a lot of the students that we have can speak Spanish, but aren't necessarily fluent in reading it. So I do think that the audio for that particular student was enough that they were able to follow along and sort of do things that they weren't able to demonstrate in a more traditional math sense.
That makes sense. I missed the very first part of what you guys were doing. I was hitting some tech issues getting in. Are there samples of some of the worlds that we can use or access?
Yes.
Yes, the links are actually at the bottom of, if you go into the, they're in the chat again, but they're also they'll persist in the abstract for this session on the SnapCon conference site.
All right, and I downloaded the slides. It kept jumping when I went to the description. It jumped straight to the Dropbox. Like I had to be really quick and interrupt it before it went straight to Dropbox.
Yeah.
No, this is really good. Thank you, guys.
Thank you.
That's the trick, how to get the littles engaged, right?
Yeah.
Thanks, Debbie.
Joel is asking, is there a plan to publish the curriculum?
So we're still in the development phase. We're working on a website, and we plan to make both the micro worlds and also associated teaching materials available through the website. And we can announce it in the Snap discussion forums when that's ready.
Available and free.
Mm-hmm. Melanie is asking, any special tips / other adjustments for distance learning?
Boy.
I think that's something we're all figuring out. We did in fact introduce the fourth micro world, the arrays, in classrooms that were on Google Meet. So that was a learning experience for us. And so I think we're still figuring some of that out.
I think one thing that worked quite well though, Melanie, is we used Google Meet because that's what this kids were used to from school. But one thing we did was walked them through how to share their screen with us, so that as they were working in the environment, we were able to, talk with them and see what they were doing, and found that setup piece particularly useful.
It also allowed other children in the class to see their screens. So there was an ability to share in the class. And then, we also had some experience working with kids individually doing that as well. It sure helped us help kids figure out where they might be going wrong, not necessarily in the micro world themselves, but they may have had, with second graders, managing windows, managing logins, managing all of the links, that kind of thing is actually much harder than working in the micro world itself. So we were able to help kids access more easily when they were able to show us what they were doing. June, in the chat, someone's asking, any experience or possibility of teaching mathematics using Snap for middle and high school students?
Mm-hmm.
Well, as Paul was showing, we're starting to extend some of these ideas into the upper elementary and then even into middle grades. Some work with factors and multiples. I just also wanted to mention that at EDC, we've also been involved in the development of the Beauty and Joy of Computing. It's a high school curriculum course for APCS principals. And while that is more like an introductory computer science course, it does have a kind of mathematical bent because that's who the people we are. So that's something you might want to take a look at. We're pretty close to time here. So I'm wondering if we should wrap up so that people can get to Jens's keynote. But I want to thank all of you, and it's been great interacting with you and hearing some of your questions. And we hope to see you throughout the next few days at other sessions at SnapCon.
And please feel free to write us.
Yes.
Yes, please do.
Yeah. Thank you so much.
Thank you all.
Bye. Thank you all.
Bernat. Thanks, Zach.